now looking at task gate 4, CUCM calls via the gatekeeper to CME, configure such that you can route calls from IP phones at the CUCM cluster from both corporate headquarter and branch 1 phones over to the CME with the gatekeeper resolving numbers to IP addresses and keeping track of the calls. Kind of just nothing extra we have to do there, but just kind of reminding you what the gatekeeper's job is. We're not permitted to use the default technology prefix anywhere in the gatekeeper configuration to route the call. Okay, if you remember, we looked at what will route a call through a gatekeeper. What was it? 3 main combinations that could do it. Routing a call to a local zone, we could do with either tech prefix plus zone prefix. We could do with no tech prefix, but we did have zone prefix and E164 registration. And then the other, or third option, was that we could have no tech prefix, dynamic, but we could have no tech prefix and no E164 number, but we could have static default tech prefix, again, different from just dynamic or regular static tech prefix. So default tech prefix and zone prefix. Okay, what we're told here, do not use the default technology keyword anywhere in the gatekeeper configuration. So the third option is out. And previously, we were just instructed after registering them the first time just to see what they look like to ensure that they do not, the E164 numbers from CME do not show up. So that limits, that by process of elimination, we've just taken out number 2 and number 3. Okay, I could just bring it back up here briefly. We just took out number 2 because we can't have the E164 alias registered. And we took out number 3 because we can't use the default. So that only really leaves us with tech prefix, non-default, but tech prefix and zone prefix. Okay? So we know that we need, first of all, a zone prefix. First of all, actually, let's just take a look over at our CUCM configuration because we need to set up some sort of way to route calls over to the gatekeeper and ultimately over to CME. Actually, now that we've logged in, let's go back to our corporate headquarter router. We did a show gatekeeper endpoints. Let's do a show gatekeeper GW type prefix, which is our tech prefixes, to see that prefix 115 hash is the Seattle zone and gateways within, and the 225 hash, asterisk anything, is the AMS zone and gateways within. Okay, so we know that we need to send calls to 225 hash, and then whatever actual DNs are over at CME. Have to be the actual DNs over at CME if we wanted to do some sort of translation, but we're not going to get into that. Just more convolution than we really need. So what we'll do is on CUCM, we will create a simple route pattern. Okay? Create a route pattern. We don't really care about what already exists. We're not routing any calls out to the PSTN or anything. We're just sending calls from CUCM over to CME. We'll create a route pattern and call it 3XXX. Okay, so the headquarter phones. Bring up my remote control application here. Without it, there we go. Okay, so we've got 1001 Jack Shepherd. I'm still having problems registering VoIP to the CME, so you won't be able to see the other side just yet. You'll be able to hear it. I don't know, do I have CIPC installed? No, you'll be able to hear it. I'll bring it up with a regular camera. On this. We'll see one side of it. So right now, if I try to dial 3001, I just get reorder tone because that phone isn't registered to me, right? Okay, so I'll just do 3XXX, which will cover 3001, even though that's our only DN. We'll just leave it in the null partition. We're not dealing with call routing today too much. And we're going to send it straight to the gateway. Rather than a route list, we're going to send it straight to the gateway of the Seattle CUCM gateway. Okay, this is our trunk over to CME. Sometimes it's better to name them intuitively, you know, maybe Gatekeeper trunk to CME. We're just doing what we were told. So now if we sent this, say OK and OK, we should now be able to dial 3001. It may not get us where we want to go. Actually, did it dial there? Call 3001. Oops. Again. New call 3001. Doesn't go anywhere, but I wonder, did that call even route out to the gateway and to the gatekeeper? Let's go back to the headquarter router, the gatekeeper, and check. Here's one of the best debugs in iOS. Debug gatekeeper. If I do a question mark, I only have gup, load, and servers. This is a hidden command called main, and there's also another one called call. Debug gatekeeper, main, and then the verbosity level. Some people like 5. I personally like 10. Okay. Note it took and show deb. Sure enough, shows us that this hidden debug is turned on. So let's try that call again. New call 3001. Anything route out to the gatekeeper. Okay. Let's just make sure our endpoint's registered. Show gatekeeper points. Yep. Okay, we've got our gateways registered. Back to CUCM. Jump out here. Make sure the pattern beginning this does. It points straight to the gateway. Right, let's see. That partition, so that shouldn't be an issue. Check and reset our gatekeeper. Trunk. Route pattern points to it. Trunk. Let's reset it. Right. Location. Actually, let's talk about this real quick because we did skip over that. Location is going to be, of course, for call admission control. Gatekeeper has its own form of call admission control. So if you are using CUCM in conjunction with a gatekeeper, you either want to use location-based CAC or you want to strictly use gatekeeper-based CAC. You could do both, but it's highly not, it's highly not recommended to do so because you simply have now 2 places of troubleshooting and 2 places of administration to think about whenever you change any sort of call admission control. On the way out of a CUCM trunk to the gatekeeper, we would first have to check location-based CAC to make sure it has enough bandwidth, and then we would have to check the gatekeeper-based CAC to make sure it has enough. calls are coming in, first the gatekeeper and then the CUCM location. So we really only need one form of CAC. We don't need it redundant. Okay, so location set to hub none, right? If we look back at the device pool branch 2, device pool branch 2 has location set to none. There we go. We need to set it to hub none, save, and reset this, which has one member, which is the trunk. And the reason is, if we take a look at the location for hub none, location for hub none has unlimited bandwidth, right? Unlimited everywhere. No reservation, unlimited. Okay, so the idea is that we'll never use location-based CAC for our trunk over to the gatekeeper. Instead, if we need any sort of bandwidth, we'll use it on, and we'll specify call admission control on the gatekeeper. All right, let's just check and make sure everything else works. All right, so we've reset that. We saw information flow across the screen from that, show gatekeeper endpoints. Try to send the call again. You know what? I know what the problem is. Previously, if we go to route plan report, all patterns equaling 3001, we actually do have a 3001 pattern, and it's currently not registered. Okay, this was because we actually had a phone defined for it, and prior to the beginning of this lab, we haven't deleted it. So I'll delete it. I'll include that deletion in the startup configs. Now, if we go back to call routing, route plan report, see the phone is unregistered because now it's registered over to CME. That was the reason the call was not going out. Okay, so go back to the phone, say new call 3001. Now it's still going to get reordered, that's fine. But what I wanted to see, in fact, let's just clear this screen off. It came through, but I want to clear it off. Try to keep it as clear as possible. New call, redial. Come over here and say undebug all. All right, so this is the output of the debug gatekeeper main 10. And remember, I said it's going to be dead on track with reading side by side with that flowchart, ARQ flowchart that we looked at. Okay, so what happens? After DNS, no name servers, we finally get to 3001 is the DNS. Remember the first question? It was, it is, Christopher, it's a great hidden command tip. In fact, it's one of the best, easiest to read debugs you'll see. 3001 is the DNS. That was the call ed number. That's what we called, right? The first question on that flowchart was, did any technology prefix match? Here, we answer that question. It failed. Okay? Next, the question is there a zone prefix match? Here, unresolved zone prefix, so we're using the source zone. Why do we pick SEA? Show gatekeeper endpoints, because the call came in from either the sub or the pub, and those are registered to the zone. How do we know the call came in? I don't know, let's do a debug RAS and do the call again. Don't do debug RAS and debug gatekeeper main 10 at the same time. It's a little too much information. Dial. Undebug all. We don't get more information. And we'll simply look at this. We received a UDP socket data from .20, 177.1.10.20, the subscriber. Why do we send it from the subscriber? Because on the CUCM trunk page, we specified this device pool, right? And if we go to this device pool has the CUCM group of sub and then pub rather than pub and sub. So looking back at that trunk is actually using the sub and then the pub for outgoing call control, not incoming. That's the job of the gatekeeper to send traffic to the CUCM or specify the IP address of which gateway to contact back to the originating gateway if CME is trying to make a call into the CUCM. But for outbound CUCM to Call Manager Express, for outbound from CUCM, that's where we get that priority subscriber because of the CUCM group. Okay, so we received the message from the subscriber. What kind of message? It was an ARQ, an admission request. And what did we do? We sent back an admission rejection. Why did we send back an admission rejection? Let's go back to our debug gatekeeper main 10 because it tells us. First of all, did a tech prefix match? No. In fact, do I still have that other sheet up? No, I'm going to bring it back up. What we need. Either need tech prefix and zone prefix, or we need not necessarily a tech prefix, but zone prefix and alias, or we need not a static tech prefix, not an E164, but a zone and a default tech prefix. Okay? Remember that. So did the tech prefix match? No. Did the zone prefix match? No. So we're using the source zone based on the RAS. It came in from a subscriber, and that subscriber is registered to zone SEA. So that's what we're going to use as our destination. So we're about to check the source side. We match the zone SEA from the inbound gateway registered to that zone. And we're about to check the destination side. Matched zone is SEA. Why? Because we used the source zone because we had an unresolved zone prefix. That's why we matched SEA for the destination side of the zone. Should be fairly clear. Then remember the questions. We were told, look back to step 1, this is question 4, and see, was there a tech prefix found in step 1? Nope, there wasn't. Kind of told us it failed, and we remember that we didn't match one. Then the 5th question was, is there an alias? Nope, not found. What was the 6th question? The default catch-all. It was default technology. Is default technology defined? 3001 is an unknown address, unknown alias, and there's no default technology defined. So the attempt to get an address information for RAS failed. So that's why we sent back our admission rejection. If you didn't follow that, you that are watching live today, you can obviously hit pause and go back. But for those of you, rather than me just reiterating it over and over again, I'll take any questions immediately for anyone live here that has any questions. But for those watching it recorded, if you didn't get all that, you missed gold in terms of how to debug Gatekeeper. This debug Gatekeeper main 10 plus, and not at the same time, but run the call again, the exact same call, but without debug Gatekeeper main 10 and only debug RAS, looking at those two outputs will definitively tell you every time, 1, did the call go through or not? RAS will say ACF if it did, and ARJ if it didn't. And then if it did not, debug Gatekeeper main 10 will tell you why. Now, by the way, we're about to show you the next level, which is that we're still going to get reorder tone. That is, the call's still not going to route through properly. However, we will soon see that the Gatekeeper configuration is golden and is routing the call. It's returning, not yet, but soon, an ACF rather than an ARJ. And so Gatekeeper's not going to be the issue in just a moment. And this is one of the things that if people don't truly understand how to read these debugs, then all they do is hear on the originating phone reorder tone. They hear reorder and they think, Gatekeeper config still sucks. It's still not working properly. No, that's not necessarily the case. It could very well be that your terminating gateway just doesn't know what to do with the call. So you need to know how to run the debugs. Very important. And you also need to keep in mind and consider what are the possible ways to route a call through a gatekeeper based on the ARQ, admission request. Okay, so we were told that we could not have E164 registration. We've already unregistered that DN. We were also told we couldn't use default technology prefix. We were not told we couldn't use regular tech prefix and zone prefix. So let's go configure those. Okay. First one is going to be here on the corporate headquarter router gatekeeper config. Do show run pipe 2 section gatekeeper just to remember what we have. And we're going to issue the zone prefix command for what gatekeeper name? Remember, interchangeably with zone name. Well, for the Amsterdam zone, right? Amsterdam is where our CME is registered in this zone, Amsterdam, and that's ultimately who we're trying to get the 3001 call over to. So for the AMS zone, we're going to register an E164 address prefixed. Okay, so in other words, not just the E164 full address, although we could do that. We could actually say here 3001. That's a very specific match. But we could just say 3 ... How do we know what we're going to be putting in here? Because of the DNIS that came across in a show gatekeeper, or debug gatekeeper rather, main 10. Debug gatekeeper main 10 told us the DNIS. So we know we at least want 3001, maybe just 3 ... Okay? So then we've got the zone prefix. What if we just go ahead and do a show deb, no debug, debug gatekeeper main 10. Actually, let's do main 5. Let's see the difference between them. Redial. Main 5 might be a little more concise because it gives us everything we need, but it doesn't keep, well, no, it does. I thought maybe it didn't show us the timers. Okay, 3001 tech prefix match failed. Still failed to match the tech prefix. However, look at this. We did match the zone prefix, match zone prefix 3 and the remainder 001. Why 3 and the remainder? Because that's exactly what we configured here. Zone prefix AMS 3 ... So we're about to check the source side. Source side, and this is why you want to do undebug all, because it just keeps bumping your screen up. Okay? Source side is SEA because that's where the call came in from. Destination side is AMS because we match the zone prefix and it routes to AMS. Zone prefix is about call lead number. However, 3001 is still an unknown address and there's still no default technology. Remember, going back to this, we still need, we have the zone prefix now, but we don't yet have the tech prefix. But wait a minute, Mark. If I do a show gatekeeper GW type prefix, I do have tech prefixes. For AMS, I've got the 225. That's true, you do. But if you remember looking at the debug gatekeeper main 10, 225 hash didn't come in prior as an actual prefix to the 3001. By the way, this also up here at the top is golden. This is actually the quickest way. Let me just show you real quick the absolute quickest way to see if a call routed through a gatekeeper. Okay, debug gatekeeper main 5, place your call, hang up, debug all, and simply look at the very first line. Does answer call equal 1? If answer call equals 1, then I can guarantee you the debug RAS sent back an ACF to the originating gateway, an admission confirm. You're allowed to place the call. Here's the IP address of who to contact. If answer call equals 0, gatekeeper's broken. It doesn't know how to route the call, and ultimately at the bottom it'll say it failed to get the address info. Okay? So let's go add in. We know that we've got a TEC prefix for AMS. It's 225 hash. And this asterisk, remember, that's not part of the actual TEC prefix. That's you need to keep this straight, that is a regular expression indicating there's more to the story. What's more? Well, 3001 is going to be what's more. So we need to somehow prefix this TEC prefix. So let's go back to CUCM. Is there any way on the CUCM trunk that we defined for the gatekeeper, anything related to prefix? Let's search for the word prefix. Oh, we've got incoming calling party settings. That's not what we're doing. We're sending a call out of CUCM, so that doesn't work. Those are all under incoming. Okay, we've got prefix DN. Again, that's for inbound calls, right? Oh, here we go. Here's the last, sorry, I went all the way to the top. Here's the last prefix, gatekeeper information, TEC prefix. Oh, so maybe we need to change this to 225. I'm going to exhaust this just because I really want you to understand this. All right, let's change it to 225. Let's see what happens. Save. Reset. I want you to really grasp everything. By doing is probably the easiest way. So we reset the trunk. We do a show gatekeeper endpoints. Let's just make sure they're registered. Oh, just show gatekeeper endpoints. Okay, they're registered. What about show gatekeeper GW type prefix? Now I've got 225 hash for both my Seattle and my AMS. Now, if we look back to our tasks, that was not what I was told to do for CUCM. I was told to register it with 115. But we're just trying this, just to see if maybe this can help us route the call over. We're just learning, experimenting. Well, hopefully you're learning. If you're not, please stop me with questions. Okay? So again, show deb, no debug, debug gatekeeper main 10, or 5 rather. Let's route the call over again. Should we see 225 as a prefix? I don't know, let's try it. Up, undebug all. Answer call equals 0. TEC prefix match failed, so it obviously didn't come across. By the way, you would see it here. You're not going to see it. Why? Because back to the screen. On the CUCM gateway trunk, this is, if you remember, I said this is who we are. If I'm talking from the perspective, from the person of CUCM. The CUCM server is telling the gatekeeper, this is who I am, not who I want to route calls to, and I was told to be 115. I'm not 225, and I can't be two people. So effectively, we'll set it back to 115 and reset the trunk. Okay, it's back to 115. We go back to the gatekeeper, show gatekeeper endpoints, it's registered, show gatekeeper GW type prefix. It's now back to 115. Gateway 1 and 2, pub and sub. Okay? There's nothing on this page that we can do. Well, how do we prefix numbers in CUCM? Okay, we haven't been over dial plan yet, but hopefully you have a little exposure to it. There's a number of places we can do it. We're going to use the absolute easiest because this isn't the dial plan section. So we're simply, since we pointed a pattern directly to a gateway, we're going to do it on the pattern under not calling party, but call led party, the DNIS, call led party transformation. We're simply going to put in who is the other side. AMS, CME is who we're trying to send it to. They are 225 hash. That's what we're going to put in here. Save. Okay, authorization, automatically resets gateways, good. Just make sure that's still registered, make sure our endpoints are still registered. do our debug gatekeeper main 10 or 5. Now place the call. Now, we're still going to get reorder, but we're going to get a lot different information. Oh, listen to that. Okay, could everyone hear that? Give me a check to let me know you're still live and breathing and following if you could hear that enunciator recording. Yeah, good. That means we got further. Hey, guess what? This answer call actually didn't show us anything, but look at down here. Answer call equals 1. So at this point, we hadn't said the answer call. The ACF was there. But here we had. All right, we turned off debugging. Let's do debug RAS and do that same call again real quick. Then we'll look at the debug gatekeeper main 10. Okay, you all got a little more res than we wanted, but from 20, the subscriber, we received an ARQ, and what did we do? We sent back an ACF. Wait a minute, let's look and see what else happened here. Oh, what else happened? We got an ARQ, which was a received parse ARQ non-standard. Okay, this is because it's an answer ARQ. Actually, here we go. Received the message from 177.3.11.1. Who's that? That's the CME voice VLAN. We received an ARQ from him. That's the answer ARQ. Am I allowed to answer the call? Guess what? The call got through all the way to the other side. We can verify that with a debug over there as well. The ARQ got through, and what do we send back? ACF to the CME. You are allowed to answer the call. That's where we have 2 ACFs. We have the answer call. Let's go up and look at the debug gatekeeper main 10. Notice 225 hash 3001. Earlier, did we have a prefix, technology prefix specifically, that was 225 hash? Yes, we did. And so here we match that tech prefix. Then we match the zone prefix of 3. Remember I said in the flow chart on the slide during concept that it temporarily, not ultimately, but temporarily strips the tech prefix, whatever it matched, to look at the remaining characters to try to match zone prefix. So it looked at that, remaining digits, which was 3001, and it matched the prefix of 3 and the remainder, because our zone prefix was 3 ... By the way, if our zone prefix was 3001, then it would simply say match zone prefix 3001. There would be no remainder. So the source side was SEA zone, the destination was AMS because of the zone prefix command, and source and destination endpoints are in different local zones. We specify the call direction. We don't have any proxies. We don't even use proxies anymore. We don't have IP-to-IP gateway, which we won't even get into today. That'll be on the special cube deep dive. And we ultimately say answer call 1, return an ACF back to the subscriber saying, hey, the person you should contact is 177.3.11.1. So CUCM contacts CME, and CME says, hey, I'm going to send a message to the gatekeeper asking, am I allowed to answer the call? Admission request to answer. And what do? There's a message from us, 177.1.254.1. Whoops, sorry about the scroll. 177.1.254.1, that's us, the corporate headquarter gatekeeper loopback interface, to the CME voice VLAN subinterface saying, ACF, yes, you're allowed to answer that call. We, the gatekeeper, are no longer the issue. We have proper routing. So why do we get a rejection? Or reorder tone or enunciator, really? Let's take a look over here on branch 2. Let's debug VoIP dial peer call. Let's try to place that call again. We already know the gatekeeper is going to route it. Okay, undebug all. Ultimately, we get result no match. But let's look up here. Start from the beginning of the debug. Right. Come on. There we go. This is where we began debugging. Okay? So we get an incoming DNIS match request, or match rule request for dial peer match to incoming DNIS. The call-led or DNIS number is 225 hash 3001. I got news for you. If I pick up the 3001 phone, which is registered to CME, and dial 225, as soon as I hit 2, I get nothing. Why? Well, let's look at our show dial-peer voice summary. By the way, this will show you all back out and do again show run pipe 2 section dial-peer. So any dial peers configured in our explicitly in our iOS configuration. Now I'll do show dial-peer voice summary. This will show you configured and explicitly and implicitly configured or dynamically configured dial peers. So I only have one possible destination. This phone can't even call the PSTN. I didn't even set the PSTN up for this. I don't care about the PSTN. Why? Because that's not the purpose of this deep dive module. In a real CME environment, of course, I would. Here, the only thing that can be dialed, the only potential DN in the system, begins with 3. There's nothing that begins with, what was our DNIS that was sent in again? Back up to the debug here. There's nothing that begins with 2, much less 225 hash. But there is some valuable information in here. It's 3001. So I just need to strip this off. Okay? So let's do that. There's a lot of different ways that I could do digit manipulation here. We're going to get into very complex ones with voice translation rules when we get to dial plan. But for today, let's use something that's really easy and also actually very safe. And as far as where this digit manipulation takes place or when it's safe to use it, the command I'm going to use called num expansion, we're actually going to talk in detail with illustrated drawings that I've created with Flash about the num expansion command, when it's safe to use, where it takes effect, all of this, when we come to dial plan. But for now, let's just use basic, without too much explanation, 225 hash asterisk space asterisk. Okay? So we're essentially saying, and by the way, if we do that debug VoIP dial peer, at the very top of it, should see if we do the debug VoIP dial peer in conjunction with the command, let's see, show dial plan. Nope. Well, show num expansion. Show num expansion 225 hash 3001 to see what it's going to happen. But there's no num expansion destination pattern. Let's see. Show dial plan number 225 hash 3001. Okay, this is what I wanted to show you. I scroll to the very top of this show dial plan number hash, and I have debug VoIP dial peer all running. Note what I get to begin with. Macro expansion. This is the result of the num expansion. So even though this didn't show what I wanted, this show dial plan number with that the other debug VoIP dial peer all does show us that macro expansion, or in other words, the num expansion command, expands 5 hash asterisk to simply be replaced with asterisk, so everything that followed. And then it tells me which dial peer matches. Okay, so just again to show the command, show run pipe to section num expansion. This simple little bit right here will route the call. Ready? And let's actually just do debug. Okay. Call routing in. Result is a success. The match of the dial peer tag is 20,002, which again show dial-peer voice summary is the 20,002-3001 show telephony service. Show telephony service dial plan shows that this is 20,002 destination pattern pointed to this port, which if we actually look further, we see is that phone. Okay, can I answer the call? Yep. I'll hit mute on both sides, and I've got audio. Now we can try things like MTP, and we'll get there, but let's not get sidetracked right now. We have a lot more to do. Now notice that 225 hash still shows up. Call ed number. Actually, it shows up as part of my call ed number, even though that wasn't something that I originally dialed. I picked up the phone and dialed 3001, but it gets replaced with 225 hash 3001 because CUCM replaces the display with the call ed number, the call ed transformation number. To answer your question, David, he asked the question, so the num expansion is sort of expanding down. In this case it is. It doesn't have to be. You know, we could have it just translate to something else entirely. But in this case, yes, it happens to be expanding down. In this case, it happens to be taking 225 hash and then any remaining digits, regular expression, and not bringing over any of the original digits, but only whatever the remaining digits were. That's the only thing that it gets translated to. Yes, a way of looking at this would be that it's translating down. Great question. Yep, we could certainly use that to expand down from 10 digits to 4, but as we'll look at in dial plan, that has caveats. There are potential issues with that, but we could use it for that. Given a carefully designed dial plan, it might be able to be used safely, but safely being the operative word. With num expansion, there's essentially, just real quick, there's no place that we can we configure it globally. There's no place to apply it. So it actually gets applied globally. And we'll actually take a look at, very specifically, again, a flash-enabled kind of presentation of where num expansion and all the other various types of digit manipulation that we could apply, where those take place, at what points, and be able to take that flash prezo with you. That'll all be in dial plan. For Gatekeeper, it's safe to say that it will certainly strip a TEC prefix fairly safely because no normal dial digits contain a hash. I shouldn't say that. We can create numbers and DNs with hashes, but a number of digits and then a hash and then more digits, that tends to be the format that we use for TEC prefix in Gatekeeper. So we kind of keep that sacred, and in that case, if we did keep it sacred and only use it for TEC prefix in Gatekeeper, completely safe to use with Gatekeeper. That's ultimately what we had to do, is strip the TEC prefix on the ingress of the terminating gateway.